Linear programming we use for multiple limiting factors. And we say that a business needs to identify the optimal production plan for utilizing its resources to maximize profit. So there will be two techniques. One is called single limiting factor, which we just finished, and the other one is called linear programming. Linear programming you use when you have more than one limiting factor. So we'll start with one example. It says that a business manufactures two products, garden gnomes and garden statues. Information for 1 unit of each product is given below. Contribution from gnome and statue. So you have $6 contribution from gnome, which means sales price minus variable cost. Contribution is $6. For statue, it is $9. Material you use 2 kilogram in gnome and 4 in statue. Labor 5 hours and 6 hours. So you see that statues, it is giving you more contribution, but it is also using more material and also using more labor. There are only 80 kilogram of material available and 180 hours of labor. Demand for the statues will not be above 10 units per week. So in this question, you have three limiting factors, three constraints, I call it. One constraint is about the quantity of material. You have only 80 kilogram. And the other constraint is about labor hours, which is 180 hours. And it says that demand for the statues will not be above 10 units per week. So this is your third constraint. Now, using these available resources, 80 kilogram of material and 180 hours of labor, and keeping in mind that statues you can only sell maximum 10. Maybe you are making more profit from statue, but you cannot sell more than 10 statues per week. So under this scenario, we have to find out what is our maximum contribution. So linear programming steps you need to remember. These are 6 or 7 steps. Every time you will follow the same steps. Step number 1, define your variables. So what are your variables? For example, let G is number of gnomes produced per week. And pay attention, we are doing it per week. So the number of gnomes which we will make. And S is the number of statues which we are going to make. And K is your contribution per week. So these are your three variables you have to write down. Like G is the quantity of the gnome, S is the quantity of statue, and K is the contribution which you have to make.
Okay.
And then you find out your step 2, establish constraints. So what are your constraints? So constraints you will write down.
Limiting factors.
Yeah, limiting factors. And you will write down like this. You will say that material is 2G plus 4S less than equal to 80. So if you remember, every gnome was using 2 kilograms. So this 2 is 2 kilogram of material, and this is number of gnome. 4 kilogram of 4 hours, 4 kilogram of material, and this is number of statue. So statues, each statue is using 4 kilogram, you multiply with number of statues, and 2 kilogram multiplied by the number of gnomes. And it should be less than equal to 80 because your material is maximum 80 kilogram. Then you make second constraint, 5G plus 6S is less than equal to 180, which means 5 hours of labor in every gnome and 6 hours of labor in every statue. And total number of labor hours are 180. I will show you again. I go back. This was our slide. If we go back, you had 5 hours here and 6 hours here. So 5 into G plus 6 into S, 2 into G plus 4 into S. So this is what you made your constraints. And the third one is that demand for statue is less than equal to 10. Like statues, you cannot sell more than 10. And then non-negativity constraint. This is very important. It says that G and S, which means the number of GNOME and number of statue, should be greater than equal to 0. You cannot be a negative in this. I mean, it is production. You cannot produce -2 GNOMEs or -4 statues. So you non-negativity constraint, you also write down that number of GNOME or statues, it must be a positive number. Step number 3, you formulate objective function. You decide what is your objective function. So your objective function here is to maximize your contribution, and contribution was K. So we say that maximize contribution K is equal to 6G plus 9S. So 6 was contribution in each GNOME, and this is number of GNOME, plus 9 is contribution in each statue multiplied by number of statues. So this is the total contribution from GNOME plus total contribution from statue, and that should be maximizing your total contribution. Okay, so fourth step is plot constraints on graph. Now you have to put it on your graph. Now what we do, find coordinates. How do we do coordinates? See there, you had this equation 2G plus 4S was less than equal to 80. Like we just wrote down that it was less than equal to 80. But let's suppose for a time being that it is 80. We are making it equal to 80 because we want to use maximum. Like I tell you, Rauf, you want to make maximum contribution, right? You can only make maximum contribution if you use all of your material. If you use your material, it says that it should be less than equal to 80. But in order to maximize your profit, you must be using all of your resources. You cannot maximize contribution by using 10 kilograms or 20 kilograms. You can only make maximum profit if you use all of this 80 kilogram maximum. So what we do, that we make it equal to 80. And now from this equation, we can find out the value of G and S. We say that if G is equal to 0, I make it 0, then S will be 20. Because when G is 0, this part becomes 0, and you get 4S is equal to 80 and S is equal to 20. Or you can say that if S is equal to 0, if you make this one 0, then you get 2G is equal to 80, which means that G is equal to 40. So we find out the coordinates that when G is 0, S is 20, when S is 0, G is 40. So these are the lines for your material. Similarly, you can find out for labor, 5G plus 6S is equal to 180. So when G is equal to 0, you have 6S is equal to 180, which means S is equal to 30. Or when you make S is equal to 0, you get 5G is equal to 180, which makes G is equal to 36. And then you have demand S is equal to 10, because this also you want to sell maximum. Now these are the 3 constraint lines we made. Now we go back and we make our graph. So this is, you take S on one axis and G here. It does not make difference. If you want, you can take G here and S here. It is no problem. You can take it on any axis. So we put S on the y-axis, G on the x-axis. And this was our first point, that material 2G plus 4S is equal to 80. So this, because it told you, this equation it gave you that when G is equal to 0, S is equal to 20. When S is equal to 0, G is equal to 40. So you say G 0, S 20. So G is 0, S is 20. You put line here. And when S is equal to 0, G is equal to 40. So you make 2 dots. You just make 2 dots using this equation. You say that, let me tell you how do you do that. You say that when G is equal to 0, so 4S is equal to 80, which means S is equal to 20. So G 0, S is equal to 20. You make 1 dot here. Then you say when S is equal to 0, so this becomes 0, 2G is equal to 80, which means G is equal to 40. And you take one dot here. And then what you do, you just join these two lines together. And this is your first constraint. First constraint is ready. So this line is actually the line for material. This line is your line for material. Then you have another constraint, which is labor. Again, if you want to see the labor constraint, we will draw ourselves. We draw ourselves. How do we do that? When 5G, G makes 0, S is equal to 6S is equal to 180. So S is equal to 30. So I make G 0 and S 30. So this is 1 point. And then you make S is equal to 0 and G will be 5G is equal to 180. So G will be 36. So when S is equal to 0, G is equal to 36 somewhere here. And then you can join these 2 points like this, and this is going to be your constraint for the labor. So the first line is for material, second line is for labor. So the second line you make it here. Okay, so their lines and my lines are a little bit different. Now I just erase my lines because I just wanted to explain you, so I just delete it. So now you have one constraint which is for material and another constraint which is for labor. And then you have the third constraint which said that S is equal to 10 demand. So S is equal to 10, you draw a straight line. So what you have done, you have calculated your 3 constraints and you have put them onto the graph. And the next step is to find out the optimum production plan. So what is happening? Let me now explain you how to understand this graph. You know, you cannot produce anything here because you don't have material or labor, because this green one is your labor. So labor is maximum here, material is maximum here. What you have here, actually your capacities are available only inside areas. You only can produce inside areas. These are the areas where you can produce. This you cannot produce anything. And in fact, you cannot produce here as well, because let me draw a point. If you want to produce something here, this level of production you cannot achieve, because at this level of production labor is available, because labor maximum is here, so labor is available, but material is not available, and plus demand is not available. You said that S demand maximum is 10, here S demand is more, you cannot sell 20 S. So this area you cannot make any production. If I speak about this area, if you want to produce something here, you have enough material and you have enough labor, because material is higher than this and labor is also higher. So you can produce in terms of material and labor, but you do not have demand, because here it says that, you know, your 15 S is 15 or 17. There is no demand for 15 or 17 S. So it means that this area we also cannot produce because we are exceeding the demand of S. So we have to find out what is the area which we can produce. So actually what you can produce is, you can produce only until this point, you know, this point, and then this point, and then this point. So in between here, this is your, you call it feasible region. You call it feasible region, which means that any level of production you can achieve within here. Because beyond this line, either your demand for S is not available, or material is not available, or labor is not available. So this area is your feasible region area. So this one is actually internally, this is your feasible region. This is something which you can produce. Now, one thing is, should at what level should we produce? If you produce, this is possible to produce, Rao, this is the level which you can produce. You can also produce this number of, like, if I take about this point, let's suppose this point. So what is this point? This point, it tells us that you can make, like 6 units of G and probably 7 units of S. So you can manufacture, you can produce, you have material for that, you have labor for that. But this is the point which is not very desirable point, because if you are using this point, it means you are not using your all of your material and all of your labor. You can produce here also. You can produce this combination, you can produce this combination, but they will not give you maximum contribution, because maximum contribution you can only achieve by utilizing the maximum resources, by the maximum production. And my maximum production possibility is here on this line. I mean, you can produce here, it is possible, but it will not maximize the profit. If you want to maximize your profit, you should produce maximum. And maximum means that you should produce all the available resources, which means you should be producing as much as possible. So these are my external border. This external border means that I am using the maximum resources, because if I'm making something like this, so I'm just making 3 gnomes and 2 statues, does not make any sense. It will not increase profit. In order to increase profit, you must go as much as possible on the border side. So now what we need to do, we have found out our feasible region, what we can produce. We know that we can produce anything in between, but the question is that how should we calculate what to produce? So step number 5, identify the feasible region. So your feasible region is A, B, C, D, and E. Any point on these lines you can produce. So step number 6, okay, so you can produce anything, but try to produce on the external line so that you are using your maximum resources. Step number 6, plot objective function and optimal point. So objective function is the line which is going to tell you what to produce, and find out the optimal point. Optimal point is that production which you should be doing. So how do we do that? So we go back and we say that our contribution maximization objective was K is equal to 6G plus 9X. This was $6 contribution from the norm and $9 contribution from statute. So you can assume any value. We say pick any value for K. You find out any number for K, because we have to find out the value of G and S, but try to pick value. Don't take value like 11 or 13. Find out some value for K which is divisible with 6 or 9, which you can divide with 6 or 9. So easy thing is that you take 54, because 54 is a number which you can divide with 6 or divide with 9. And now you do the same exercise. You say if G is equal to 0, S is equal to 6. If S is equal to 0, G is equal to 9. And now the same, this objective function, we are going to put it here. K is equal to 6G plus 9S. So this is the function. It is called your objective function, isocentric line you call it. And now what you need to do, now you cannot produce at any level here. You must be producing outside. You must be producing. What you need to do now, you need to extend this line outwards. You need to extend this line outward as much as possible until it will touch this point. So you will take it, you will push it forward. You will push it forward physically, manually. You can put your foot ruler, you can put your scale, your foot ruler, and then start dragging it until it touch this your possibility production possibility frontier, you call it PPF, until it touch this PPF, and you will wait until it touches the last point. So how it is done, you will have to move it upward until it will touch there. So this is going to be the last point. Now let me tell you what will happen. When you will move it upward, it may touch here. First it will touch here, but this is not your point. Then you will move it further, this will come and this point will touch here. You will continue until this point will come and touch here. So the last intersection, the last touch you will do. You will make it, push it forward until the last point. So D, this is going to be your optimal point. This is the production point which you should be making, which means that at this point, if you want to see, it would be something like, like this and like this. So this is the number of G's and number of S which you should be making. Maybe 30 G or maybe, I don't know, 6 S. Now this is visibly, probably you did it manually. So there is a possibility that you make some error. There is a possibility that because we calculated it manually, we may make some mistake. So we can also do it mathematically. So now we'll try to see how to do it mathematically. So now we do it mathematically to find out the answer more accurately. So linear programming steps are solve using simultaneous equation. So if we are doing it with simultaneous equation, we can find out the answer more accurately. What you can do that, you say that materials 2G plus 4S is equal to 80, labor 5G plus 6S is equal to 180. These were the two equations for our constraint. And you can find out, rearrange equation 1 to get G on own. So you find out the value of G from equation 1. So you say that G is equal to 40 minus 2S. We divide it with 2. So it becomes G plus 2S is equal to 40. So G plus 2S is equal to 40 means G is equal to 40 minus 2S. And this value of G we will put in the second equation. And we put the value in equation number 2, which is 5G plus 6S is equal to 180. So it becomes 5 into 40 minus 2S, like the value of G, plus 6S is equal to 180, and it is like S is equal to 5. So you find out the value of S, the number of statues. So it means that you should produce 5 statues maximum. And then we use this value of S, we put it here in the first equation. We put S here, 5, and we get the value for G. So you get G is equal to 30. So it means that your G is 30. So S is equal to 5 and G is equal to 30. Now if you go back and see here, S is equal to 5 and G is equal to 30. That this point is somewhere here, S is equal to 5 and G is equal to 30. So visually it is also quite similar, quite close, but you need exact answer. You cannot make it, 31 or 29. So in order to be more accurate, do it with the equation. And then you put it into your objective function. Your contribution K is equal to 6G plus 9S. And you put G6 is the contribution from 1 genome, and you produce 30 genomes. And 9 is the contribution from 1 statue, and you produce 5 statues. So your maximum contribution is $225 or 225 pounds. So this is like, if you have these limitations on material, labor, and statues, if these are your limitations, this is the maximum what you can produce per week. This was weekly maximum contribution.